the 86 billion neurons and trillions of synapses are just the start. Once we understand all that wiring, that's a pointer to software outside of space-time that's generating space-time as a headset. So whatever you are, you transcend the headset. You are the author of this headset. And that means that you're quite special. You're not just, as Francis said, a pack of neurons. I'm not going to do a technical talk. I'll just give a flavor of the direction I'm going in trying to figure out what I am and why. Here's a very, very simple example where here's a simple observer that has 4 color experiences. That's all this simple observer has. And now it's seeing purple, now it's experiencing red. I'm just growing one to say this is the current experience. So this observer is having different experiences and they're switching. And we can just model observers as having a certain number of experiences and changing from experience to experience. And we can write down what are called Markov matrices. So I've got a little Markov matrix on the right there, which says if I'm seeing red now, chance is 20% that I'll see red next step, 30% that I'll see green, 10% that I'll see blue, and 40% that I'll see the yellow or orange. So it's just a Markov matrix. So the very, very simplest kind of assumption that I can make. I have experiences and they change. And I can write down the probabilities that they change. The question is, how far can we go if we just start with that? If I just model us as having experiences and changes, and then I can ask, suppose that the experiences and changes I'm having are governed by that matrix, but suppose I only see, say, the red and the green. I can then write down a matrix for what I would, the chances of, if I see red now, I'll see green next, and so forth. And so I can, if I actually do the math, I would get this answer. It's actually a calculation that I did. And so there's going to be a relationship between observers. Here's an observer on 4 colors. Here's a related observer on just the 2 colors, red and green. But it's governed by the same matrix that governs this observer. So you can see there's going to be there could be a relationship among observers, and it turns out that there is. You can write down what's called a trace. There's a formula that shows you how, if I have a big observer here, then I can give you a formula for what the little observer will see. This is called a trace. And what I've discovered is that this gives us a logic on all observers. So there's a mathematical logic that gives you the notion of conjunction, disjunction, implication, negation among all possible observers of an infinite number of experiences. So there's this logical relationship, and I call it the trace order, based on this notion, this mathematical equation that I just showed you. There's a trace. So this is new. I've only had this in the last 2 years. I've been working on this since 1979. So you got to be persistent. You just keep persisting. And the last 2 years, I've kept going at it, and I discovered this logic that no one had seen before on the set of all possible Markov chains. So this is actually mathematics, contribution to mathematics. This is a logic on all Markov chains that no one had ever noticed before. So this logic on all Markov chains can be interpreted as a logic on all possible observers, and then I can do a recursive thing. Well, it's also minimum surprise. So it's a logic not only of observation but of intelligence. You can prove that the trace matrix is the matrix that has the minimum surprise. If this is what's governing your world, then that's the minimum surprise matrix if you can only see red and green. So it's actually the minimum surprise matrix as well. And there's a lot of work on active inference and so forth where they're trying to estimate surprise and trying to minimize it. We can compute it directly and show that there's a logic of minimum surprise. And that's a logic of intelligence because in some sense, if everything I do, if every action I take, I'm surprised at the outcome, then I'm not very smart. If I go to pick up a glass and it falls to the floor and breaks, then that's not very, if I pick up, if I try to shake your hand and I squeeze it too hard and it hurts you, that's not very smart. So if I'm surprised by the outcomes of my actions, I'm not very smart. So minimizing surprise is a big, big aspect of intelligence. And so this is a logic of observation, but also a logic of intelligence. And this logic is non-Boolean. It's not a Boolean logic. It's a very, very interesting non-Boolean logic. But if you take any particular Markov chain and look at all the observers underneath it in the trace logic, they form a Boolean sublogic. So this is just a little technical, but I just wanted to show that there is some beef here. And it turns out then you can go from the notion of observer to a notion of an agent. You think about agency as I'm looking at the world through this window right now, this observer window, but now I want to look at the world from over here or like there. I can look at the world in different ways. So I need to be able to change which of these windows. I was showing you those observer windows. And how do you do that? Well, I can write down a Markov matrix that says if I'm looking at this window, what's the probability that I'll look at this next window over here? So once again, I get a Markov matrix for how I change my observer windows. And I get the notion that an agent is a Markov chain on the trace logic. And then I get that a set of agents has its own trace logic. So this is recursive. I have the trace logic on observations. Agency is walking around those observations. All the ways that you can walk around and look at through the different windows has its own new trace logic. And then I can keep recursing. Agency builds even nested layers of agency, recursive trace logics.